Hello, my name is Deborah Paul, and this is the 10-second leader. Greetings. Hi, my name is Deborah Paul. I'm pleased to be here with you as the Biodiversity Informatics Community Liaison from the Species File Group and as current chair of the International Biodiversity Informatics Standards Organization, TDWG. Humans do the work to reveal the interconnectedness of life on the planet that supports it. Taxonomic names and related metadata and media underpin this critical research. These scientific endeavors across disciplines support local to global initiatives such as species discovery, conservation assessments, crop science, and predicting pathogen-related spillover events. How do you use taxon names? Consider your own scientific reliance on taxonomic information through the lens of a user story. What issues arise for you when using, tracking, and trying to keep up with taxon names, media, and related information? In a minute, we'll take a tour through some specific examples of the ways in which taxon names and associated information support research and resources, varying in both scale and scope and challenges. Next, consider the negative case. How would your research and your ability to report on or offer substantive information for decision-making be affected if you didn't have taxonomic names applied to the relevant taxa observed, sampled, or gathered? What research questions would remain or become impossible to address? What roles can you play to support attribution of taxonomic work and synthetic use of this information, along with new knowledge integration as taxonomic knowledge evolves? Please note where you have agency. In our first example, the GBIF backbone taxonomy currently aggregates names from 94 sources to make searching possible across millions of records of GBIF. Note that the mappings shown here between taxon names in different authority files come from Wikidata. It takes a lot of work to create, maintain, and continually update this resource. It also helps us to see taxonomic gaps, as well as capacity and technology gaps. The Catalogue of Life is the top supplier of names to GBIF's backbone taxonomy. Now in action for 20 years and with 1.9 million species names, the Catalogue of Life has a new standard data package, an API to access the names list, and new editing and data quality tools. Species File Group members Jeff Ower as developer and Yuri Roskov as executive editor are part of the Catalogue of Life team. From the Biodiversity Information Standards TDWG group, several new standards are in development. For example, the Humboldt Core Task Group is working toward a standard for ecological species inventories so that these data sets can be aggregated in the future. See Map of Life for an example reference implementation. Another standard, Audubon Core, for sharing media metadata. And often media information is sadly sparse, making it quite difficult to search through millions of images for the subsets you need for your research questions. Implementation and adoption of standards remain challenging once the standards are in place. Continued work needs to be done to ensure that the standards are implemented in such a way that the appropriate data are found in the expected buckets. Next, we discover bionomia, where occurrence data aggregated by taxonomy in GBIF is now pivoted around people. We can look up data by searching for a person to see what they've collected or identified and who they work with. In addition, we can see what publications have cited particular specimens. And here we see Jennifer Giron's specimens sent from Bionomia to Zenodo, where they've now been downloaded 105 times to date. In a few more examples, one is GLBIO, currently in year 9 of 10 years of funding from the National Science Foundation as part of the Advancing the Digitization of Biodiversity Collections program. Key efforts of GBIO include community and capacity building in support of collections in their efforts to digitize, and this often includes imaging of the vouchered specimens. DISCO, the Distributed System of Scientific Collections, is currently ramping up to go live in 2024. They're working toward building a 122 museum network in the European Union across 21 countries to support digitization driven by researcher needs, and on developing tools like the Specimen Data Refinery for automated trait data extraction from images. From the Species File group, please meet TaxonWorks. As a taxonomic workbench, TaxonWorks supports curators and taxonomists with software that is tailored to meet their needs while being future aware at the same time. For example, tools like soft validation help ensure the quality and completeness of the information being documented and linked. Anyone interested can and is encouraged to contribute to the code base. More from Matt about TaxonWorks in the next talk. The Biodiversity Heritage Library brings us millions of books, searchable in the aggregate through OCR and the integration of the Global Names Architecture suite of tools, which make it possible to see and find all taxon names in a given text and across the corpus. Future development includes searching similarly for people and places. Global Names is also brought to you by the Species File group and developer Dimitri Mazarin. Back to Europe, the Biodiversity Community Integrated Knowledge Library project has just been funded. It starts in May. It's 3 years, 5 million euros, will build a European new research infrastructure that links existing infrastructures, giving access and tools for seamless linking and usage tracking of data from specimens to sequences to species to the resulting analytics, publications resulting, and the biodiversity knowledge graph that can be built with this information, leading to reuse. Next, in this example, we highlight linking through taxonomic and related metadata. We'll start at the Plecoptera Species File group. These are researchers studying stoneflies. They published a monograph paper in Zootaxa with the new species described. Through the Plazi project, sections of the paper, including taxon names, species descriptions, and images are pulled out, tagged, and uploaded to Zenodo. From there, we can see the resulting derivative treatments in Treatment Bank. GBIF ingests the taxonomic names and images from Treatment Bank into the backbone taxonomy, and the resulting data can now be pivoted around people, and we're back to bionomia. All of this is made possible through the use of persistent identifiers and semantic markup. In this final example, we note the evolution of taxonomy at different levels. In this case, the researchers are looking to meet the needs now of those doing conservation work, of macroecologists, for example. To get these scientists a working data set quickly, the authors provide essentially 3 pieces of evidence: a sequence for a specimen, an image of that specimen, and note that the specimen is vouchered for reference, reproducibility, and future work. This approach speeds up access to information for many more specimens with the relevant data needed for the research questions. It also then allows other taxonomists to expand on the work if desired. This approach continues to become more feasible as sequencing becomes cheaper and faster, and naturally will provide a suite of images for research linked to a genetic sequence from the start. Some resources used in this talk here, others are cited directly on the slides for you to visit, and I hope to have some questions. And in wrapping up, keep in mind that the underlying themes present. We're looking forward to hearing your thoughts on these many topics and which are relevant to you and where you might like to collaborate. Where's your agency in the conversation, knowing that specimens ground taxonomy, and how can you add to the global knowledge resources? What about metadata, citation, and attribution, all key for metrics, discovery, and linking? Thanks a lot to my colleagues at the Species File Group, Plazi, and all of you. And thank you to our symposium conveners for the opportunity to be part of this conversation.